Variables as API contracts. Today, we shift perspective. A variable is not a convenience. It is not input storage. It is an interface boundary. It defines what meaning is allowed to enter a configuration. When you declare a variable, you are publishing a contract, and contracts shape graphs. That is the frame for today. Terraform builds a dependency graph. Inside that graph, resources relate through references. Outside that graph, humans and systems provide input. A variable is the membrane between those two worlds. Think of the variable as the airflow intake of an engine. If the filter is loose, the engine eventually chokes on unexpected debris. Cause and effect. If the boundary is strict, the graph is predictable. If the boundary is loose, the graph absorbs ambiguity. So we must understand what Terraform infers from a variable declaration. Not how to use it, but what it means. This declaration does three things. First, it creates a named entry point into the graph. Second, it constrains the type. Third, it signals that the configuration expects external meaning. Terraform now treats instance name as part of the module's public surface, not internal logic, public surface. Observe the flow. var.instanceName enters the graph. It becomes part of a resource argument. Terraform infers the dependency from the resource to the variable input. The resource's identity now depends on external data. Cause and effect. If the input changes, the resource may change. The contract influences structure. The type is not decoration. A type constraint is compile time guard. It stops a bad plan before a single API call reaches a provider. When we declare type equals string, we are limiting acceptable meaning. Terraform validates the boundary before graph construction proceeds. If the type constraint fails, the graph is never built. Types protect graph integrity. A contract that cannot be validated is not a contract. Now the contract is structural. The configuration no longer accepts a single value. It accepts the defined shape. Terraform now expects both subnet ID and AZ. If either is missing, validation fails. The boundary becomes explicit. This protects internal assumptions because downstream resources may rely on both fields existing. The contract prevents partial meaning from entering the graph. Resources have identity. Identity is shaped by arguments. Arguments may originate from variables, so variable contracts indirectly shape resource identity. If a variable feeds into a name, a tag, a count, or a for each expression, it influences instance addressing. That means variable design affects state stability. An unstable contract produces unstable identity. This is not a syntax concern, it is a lifecycle concern. Here, the contract controls multiplicity. Terraform will create as many instances as the input specifies. The structure of the graph depends on the variable. If the value changes, the graph expands or contracts. Now the field note. In a high-stakes environment like a bank, changing a variable type from a string to a list, switching from count to for each, is not a cosmetic refactor. It is a resource destruction event. If that variable defines the identity of a database or a stateful firewall, you have triggered replacement. And replacement of stateful infrastructure can mean outage. The contract is not just about what enters the graph. It is about the life support of resources already recorded in the state file. Refactoring a contract refactors identity, and identity governs lifecycle. A variable may include a default. That changes the contract's posture. Without a default, the input is mandatory. With a default, the input becomes optional. This signals intent. Mandatory contracts enforce explicit decisions. Optional contracts permit omission. Each choice affects how the module is consumed. Variables may include metadata. One example is sensitive equals true. This does not encrypt the value. It marks the value's lineage as sensitive. Terraform then protects that lineage in plan and output context. The contract carries classification. If the boundary marks data as sensitive, Terraform treats downstream references accordingly. The contract influences visibility behavior, not resource logic. Inside a module, variables define its API. They declare what the module expects from the outside world. Nothing else should be required. If internal logic depends on undeclared external assumptions, the contract is incomplete. A complete contract produces predictable composition. Variables are the input side of that boundary. Outputs are the exit side. Together they form a stable interface. There are two common risks. First, overly generic contracts. A variable named config with type any accepts nearly unlimited meaning. That weakens predictability. Second, structural contracts that influence identity without clear documentation. For example, account-based contract without warning about replacement effects. The risk is not failure. The risk is surprise. And in production, a surprise is just a polite word for an incident report. Stable infrastructure depends on explicit contracts.